So this is the Joule power tree branch, and this is actually the heart of the system. You might think the heart of the system is in the trunk, but most of the smarts to the Joule power tree, in fact most of our intellectual property, is located in a microcontroller and associated circuitry in the stem of the branch. This branch has a plug here, a connector, that this is what it's used to connect to the DC bus of the Joule power tree in the trunk. And when you plug this in, it connects itself to the DC bus in the trunk. Incidentally, this branch weighs about 5 pounds, so it's quite light to handle, to plug in and take out of the branch. And each branch has between 60 and 75 watts of solar panels. This one in particular has 60 watts of solar, as does this one. We have another model with more leaves rather, that have 75 watts. And as far as the trunk is concerned, the trunk is capable of accommodating 6 branches, and it's scalable. So you can operate the Joule power tree on either 8 branches or 12 branches, or any number in between there. And we have other accessories that you can plug into these unused sockets to provide, like a 5-volt USB power hub, or a 12-volt lighter adapter hub that you can use on your deck, as I say, on your deck or in your yard, to charge your cell phone or your smart device. Some of the other features of the branch, along with the microcontroller inside, implementing a smart sun tracker with several different layers of functionality. The first layer is kind of obvious. You've probably seen these sensors here that sense the direction of the sun, or actually sense the sun, and give that information to the microcontroller that drives the motor system that aligns the branch with the sun to optimize or to maximize the amount of solar current generated. The second layer of sun tracking is time of day and direction awareness. So the microcontroller, through the use of a real-time clock, knows what time of day it is. So if it's, say, 9 a.m., it knows the sun is in the east. And because it also knows what its orientation is relative to north, south, east, and west, it can orient itself per time of day to try to align itself with the sun. The third layer of smart sun tracking is the communication capability of each of the branches that are mounted in the tree. So if one branch, say, is producing a lot of power, it's obviously well aligned with the sun, it can tell the other branches where the sun is so they can align themselves accordingly. Another cool feature that we've implemented in this branch is what we refer to as pico power harnessing, which is the use of diffused or scattered sunlight to generate DC power. A conventional system, when there's cloud cover that interrupts the sunlight, or clouds that come between the sun and the solar panel, the output doesn't just fall, it drops off to 0, because that inverter in that system doesn't have enough power to run. That same threshold in the Joule power tree, the branch of the Joule power tree, is very, very low. So the branch of the Joule power tree is capable of using even diffuse sunlight to generate current to charge a battery and to run the inverter. Another technology that we've implemented is shading compensation. So if one of these leaves are shaded, it doesn't affect the output of the branch, which is an issue that conventional systems have. As I mentioned, the capability of each of the branches in terms of Bluetooth Low Energy, we also have an app that you can interface to each branch individually to determine the power output of the branch, the status of the branch, and the like. Some of the other functions that we have in terms of sensors, we have a high wind sensor that senses the effects of high wind on the branch. So if you have it out in a tornado or a hurricane, you can, before the bad storm comes, you can remove the branches and take them in the garage to protect them. If you don't remove the branches during a hurricane and a tornado, I'm sure that the hurricane or tornado will remove the branches for you. Another cool feature that we have is a touch sensor. This aluminum U-channel that acts as a kind of the backbone of the branch is also a sensor. So if you touch this anywhere, there's a capacitive sensor that detects that touch, and it will alarm the user through BLE, then through Wi-Fi, that someone is possibly tampering with your Joule power tree. The last feature I'd like to talk about is NFC. So in order to make it easier for users to interface their smart device with the Joule power tree, with the Joule power tree's branches, we've implemented an NFC tag where you just bring your phone close to the tag, it reads the tag, launches the app, and the tag also tells the app which Bluetooth low energy address to address for that particular branch.